Hi. Today the main topic is the B tree. Like I was studying about B tree, and I finally realized that B tree. I finally learned how to implement the B tree and search part with the and also inserts. Um, Actually, the B tree was really kind of hard to me because, like, I'm not really friendly about data structure, and I didn't rely on the some kind of already made code. Example, if you search the how to implement B-tree with the JavaScript, there's a bunch of code up there, but there's no fully good code. It's just the old code, and I think there's so many weird name of it, so I just implement it by my own. So I like 90% or 80%. I think 85% I implemented by myself without looking at some kind of like the internet or ChatGPT. I just like draw it, and I finally learned how to do the insert thing. Okay, but before you make the bit tree, you have to make some kind of rule of it. The which rule you have to set the maximum keys that node has. If there's a lot of keys, it's pretty fine, but you have to like set the maximum keys up there because if you don't set it, that's just the bunch of array. And now let's say we have the maximum keys is gonna be maximum key that be per node, max keys per node. Let's say it's 3. Now let's begin. You have 50, 40, and 30 to 100, and you have to put this into B-tree. The first thing the B-tree is, the first thing you have to understand the B-tree is, it's kind of hard. I'm just gonna give you an example. You have 50. It's pretty nice. You have 50. Wait, hold on. And also you have to make some kind of, I don't know, never mind, just like it. Let's do it like this. Let's say you have 50, and now you insert the 50 key on the node over here, and next is a 40. The 40 is pretty fine, but let's just put it here. And next is 30. And we just realized that we already have the maximum keys in node. So in the B tree, when you face this kind of problem, you should select the one key that's gonna be become the primary key. The primary key, what I believe is the key that is going to be the parent node of it. For example, in here the primary key is 40. The 40 is gonna be parent node of here. So this 40 is gonna be here. And next, the 40, the primary key already go to the upward of here, and it's gonna be deleted. And 40 key, we're gonna reference this kind of value, 30 and 50. So let me try to simplify more. And you have the 50 for is 30. But before we begin, you have to select the primary key. To select the primary key is really simple. Your key, the maximum key per node minus 1. The reason minus 1 is, it's not kind of really a formula thing. It's kind of really natural thing. The reason why we minus 1 is because we have to select the middle index of here. And of course we just made this 3. We just made our own rule of the maximum keys per node 3, and 3 minus and the maximum index is actually not 2 over here, in actually 1. So the index is gonna be the primary index is gonna be 1. I mean, of course, because it should be 1 because the array is gonna stop it from 1 to 0. To select the middle key of here, you have to select the 1 index of this node. So now we just define our 40. But what if we just switch this part? What if the 50 is gonna be middle and 40 is gonna be the 0 inside the 0 index of here? So those kind of confusion those kind of things make us to lead to confusion. So in the B tree, the important part is that you have to short these keys of here when you're trying to insert it or not insert it. So when you're trying to like manipulate or get the value of it or to insert the new keys in your node, you have to short it. So now basically when you're trying to short it, 30 is gonna be go here and 50 gonna be go here and 40 gonna be go here. That's perfect. And now there's no children of here, it's just here, and you now have to make the parent node of here. The parent node here, we just already know the primary key index, which is 1, and we make the 40 as a parent node. But the thing is that the B tree actually it's just the enhanced version of the binary tree. The characteristic of the binary tree is that the left node, it has to be a smaller value than the parent node, and the right node gets bigger than the parent node, and that's really valid in the B tree. So when you're trying to you have to split into 30. You have to split 30 into 50 because when you're trying to delete the 40, and if your 40 is pointing the node which has 30 and the 50, it's gonna be hard to decide this is left or right. We have to split it into here. So now the 30 is smaller than 40, so 30 is gonna be left on the 40 and 50 is gonna be right on the 40. And that's how it really begins. But I think this is really pretty simple, but next part is getting hard. When you're trying to insert 20, it's just like inserting in the binary tree. You find the smaller value, and if there's smaller value, you insert the left part. If it's 20, you're just trying to insert the 20 value, 20 key, and you look at the 40. Okay, it's a smaller, and you go left of here, and you check the 30. If it is smaller, and you push into this kind of key, and this kind of different part of the binary tree. The binary tree is that you just create a new node regardless of the how many node it has. The binary B tree is just the enhanced version of the binary tree, because the B tree, the biggest difference between the binary tree and B tree can have multiple value in the one node. That's kind of key difference of it. So that's why we just set the maximum keys per node. Since we are not the length of these keys is still 2. We don't really create the new parent node here, and we just trying to put here, and of course you have to short it. Nice. And next part is 10. 10 is also the smaller than the 40, and it is smaller than the 30. And in this part, there's no the child node up here. This is already the end of the tree, and you have to insert this 10 into this node. But we also encountered that the node is already full. Node is became the full. So now we just trying to do the same stuff what we did into 40. The 20 is the primary key. The 20 key is gonna be parent node, and we have to split this like this part, because the 10 is smaller than 20 and 30 is bigger than the 20. But the weird thing, but the part is that you don't really separate those kind of thing. What I mean those kind of thing? We have we already have a same pointer that is referencing. The binary B tree, the core impact, the core thing about the B tree is that the node have multiple keys. So we don't trying to separate this kind of parent node into this kind of foreign node. And also the problem is this kind of stuff is that even though we want to find 30, we have to traverse the 20 and 40. We just have to go to 20 and also have to go 40. But the question is, why don't we merge this kind of 20 and 40 like this? The 30 is bigger than the 20 and is go right of the 20, and 40, the 30 is smaller than 40 and it goes to the left of the 30. And now, and that's very simple, and the node and the rather than the previous one, this is more compact and simple. And let's say we insert now 60. We don't really trying to put the 60 on the root of the or the parent node. We have to insert the key inside the node that this node has no children, and that's called leaf. So we already know the 50 is already leaf, and we have to just insert the 60 here. And now, and we just trying to repeat the same thing that we just did. And let's say we insert 70, and now we just we already have already full keys of node. So we just make 60 as a primary key and we merge into here. And 50 is gonna be like the between the 40 and 60. But the thing is that the root of this tree already encounter the maximum keys, and we are also trying to do the same stuff. We find the primary key and we make this 40. We make primary key as a parent node of here, and we put pointer and next. And also we have to merge it 20 and 60 because I mean there's already a duplicate pointer of here. So now this is kind of the thing in the B tree. So since this B tree is very really good for the search. Example, you wanna say, let's say you wanna find the value 70. Since you wanna find the value 70, you don't have to go to the go to the other pointer because you just have to find the node that is bigger than the smaller than 6. I mean like bigger or smaller than 70. Let's say we wanna find the bigger element than 70, but there's no bigger element 70, so we just go down. We just go the right children, and also if it is bigger than this, it is 60 is smaller than 70, and we go right, and that means that we don't have to traverse or the unnecessary node to search 70. We just only find this. We just have to traverse 1-2 nodes over here, and that's really simple. And if it is, there's like a lot of nodes of here, and we can just increase the max keys per node. If we say, let's say 100 or 50, or let's say 50, that means that the nodes the B tree, the depth of the B tree or height of the B tree is still small because we just enlarged the node of here. So that's kind of characteristics of the B tree. So tomorrow I'm just gonna deep dive into how to make the code of the B3, insertion part from scratch. So this is it. Have a nice day. See you next time. Bye bye.